Okay, this is problem 2 in homework 4 about nodal analysis, and here's my version of that. Your version will pretty much be the same, but just with some different numbers. So first thing we've got to figure out is what sort of equations we need, and remember we're doing nodal analysis, so we need to look out for freebies where there's a voltage source connected between the reference node and a non-reference node, so V1 gives us a freebie, and supernode voltage sources, so V2 is connected between two non-reference nodes, VB and VC, so we need to do a supernode around VB. So that gives us those voltage source equations mean we need to have two KVL equations, whereas normally with nodal analysis we'd have KCL equations, Kirchhoff's current law equations. So now we're doing two KVL and one KCL equation. Okay, the first equation, the KVL at A, is, as I said, very straightforward. It's just VA equals 10. The super KVL, so we need to make a supernode around V2, right? So let's make a supernode around V2. And we're going to look at all the currents flowing into that supernode as part of our super KCL equation. That's looking at it from the outside. On the inside, we need to make a KVL equation, right? And the KVL equation is nothing more than VB minus VC equals V2. In this case, V2 is 5, so VB minus VC is 5. Then all the currents flowing in should sum to 0, into the supernode should sum to 0. So VA minus VB on R1 is 6 ohms. Then it's 0 minus VB on R2 is 4 ohms. Then it's 0 minus VC on R3, which is 5 ohms. And then it's VA minus VC on 6, where R4 is 6 ohms. Now you'll notice I've chosen the current direction here to go against the passive sign convention for V out. At the moment I'm completely ignoring V out. When we come to finding the output voltage, I will have to take the polarity of V out into account, but at the moment I'm just interested in the current flows. And then I took all of those equations and I made a Matlab equation. So there's my KVL at A, there's my super KVL, there's my super KCL. There are the constants on the right hand side for each of the equations, and then I just did that in order to using RF to get the answer, and the answer came out to be 10 volts, 6.5957 volts for VB and 1.5957 volts for VC. Then to get the answer I want the output voltage V out, so it's VC minus VA. So VC minus VA. In fact, I didn't even finish the calculation there. I just put the subtraction in and gave the appropriate units, and it told me I was done. So that is question 2 for homework 4 about nodal analysis.